Welcome to the ArcGIS Runtime Building 3D App session. My name is Rex Hansen, Product Manager for ArcGIS Runtime, specialty in .NET and 3D. I'm joined by Adrian Mario, who's our lead dev in 3D in Runtime. And we're gonna walk you through the next hour of sort of the 3D experience as it comes to Runtime. We're in an interesting room. This is usually like a hackathon room as far as I recall in the past. So it's quite broad, quite spacious. I'll try and keep my voice down so it's not too loud because I detect an echo actually coming back. Okay. So unfortunately, we had to adjust this session because we were originally later today, so we came a little early. So I'm glad you guys found this location, a little kind of off to the side of the conference center here. So thanks for joining us. Let's go ahead and dive right in. A quick agenda, what we're going to cover just briefly, 3 sections. First, we want to take a look at 3D across the board. Like, why is 3D important? Where's it being used in the platform? How is it being used to solve problems? And then where does Runtime fit in that story? Then we'll dive into some of the 3D capabilities in Runtime. We'll talk specifically about 3D capabilities that we've added over the last year in a couple of major updates. And then we'll talk briefly at the end about road ahead, what we plan to do in the future. So let's dive right in. So in general, 3D, ArcGIS 3D helps customers do a variety of things. Right, whether you're working with creating or managing 3-dimensional data in some capacity so that you can extract and utilize that data in some format, or you want to be able to just visualize and analyze your data more effectively, 3D is going to be able to provide you that experience. Design and simulate and using some of the tools that we have on the back end and being able to produce results that you can share are pretty critical. And so being able to work with within 3D as a more realistic representation of our physical world is valuable. And so we're seeing 3D capabilities being used in many different industries within GIS. And so whether you're working in scientific visualization or mining industry, developing energy resources, or assessing your environment, you're working in the field or you're working in the back office, 3D is actually providing you with a variety of different capabilities to better view or visualize or analyze and work with your data. So a number of industries are utilizing this capability in a variety of ways. So 3D across the platform. So we're actually, 3D is being introduced in different ways across the platform, whether it's data sources that we're working with and being able to curate its operations or its analytical capabilities, or it's the ability to just display and interact with that data. We're providing a variety of different entry points for that information. And so whether we're working with a server to be able to host and publish data and operations, or working with desktop to be able to sort of curate that information, or online to be able to host this in a more pervasive, on a more pervasive sort of cloud platform for sharing this information, or working on the web, being able to take your information and present that in a web context more effectively. Whether you're working with analytics or a data that's online or local, there's a variety of ways to make that available. So the one thing that we're highlighting here is working on devices, right? So Runtime is designed to work as a native SDK. It's designed to work with device capabilities, resources. It's also designed to work offline. And so those are 2 critical needs, critical use cases that Runtime really flourishes. And so we want to be able to showcase some of the capabilities that we have in Runtime, targeting devices, and this might be desktops or mobile devices, that enable you to take advantage of where 3D is present within our system. Great. That's the desktop. Nice. So just a brief look at Runtime. So Runtime, brief history of Runtime. We initially introduced 3D capabilities in ArcGIS Runtime in 10.2.6 of .NET, and that was about 2.5 years ago. It was our initial release, actually, in a commercial product, but it wasn't available across all runtimes. And so what we ended up doing in general with Runtime is we pulled back and we reconsolidated, reoriented our core logic within Runtime so that we could better share that functionality with all SDKs. And so this is really our 100.x generation of the product. We codenamed it Quartz. But that effort, we were able to target more effectively a modern architecture, a modern structure, so that we could target multiple platforms and expose 3D functionality and other functionality more consistently across every platform. So that meant that we could target 64-bit capabilities. We could work with local data more effectively. We could work with cloud information, service endpoints, and service capabilities. Obviously, it's multi-threaded, so you can work and you can leverage the multi-threading capabilities of a native application. And the critical part here is the common APIs. So if you're working in 3D, whether you're working in iOS and you're a Swift developer, or you're working in C# and you're a .NET developer, the API should match, right? The capabilities should match given that the platform supports it. And that's critical, a critical addition to this modern architecture. Just a brief overview of what Runtime looks like as far as its SDKs that are provided as products for developer integration, and the core bits of logic that are shared across every product. In the top here in green, we can see entry points actually to Runtime. So these are 6 different products that we deliver. And those products are designed to integrate within a developer environment that promotes the targeted platforms that are supported by that development environment. So in some cases, we have products like .NET, which can target multiple platforms, like Windows, iOS, and Android. Or we have something like iOS, which is designed to target iOS devices specifically, right? The key here is that we're providing a developer experience for the environment that you or your dev staff are most familiar with, right? Instead of providing one size fits all, we're actually providing a number of different SDKs with integration capabilities for those development environments that make sense. The key here is it's all built on top of a common core. So a vast majority of the logic that goes into rendering, accessing, and working with those data sources and capabilities is all shared under a C++ core designed to optimize for performance, rendering display, as well as access and operational capabilities. Right? So all this is optimized at a native level, and we're wrapping this in managed APIs. The middle piece here, the common API, is where within our managed APIs, we wrap and then provide a consistent API surface, actually across all of our SDK products. Great. So all of this work actually impacts what Runtime can do, right? So whether or not we're supporting 3D in many different areas across the platform, whether it's data sources, service endpoints, being able to provision or create local data in some capacity and curate that in our desktop products. Inevitably, when you're building out a client that works with 3D and you're building out a native client, you need to be able to support native experiences. That's where Runtime comes in, right? And so built on top of this common core, we've incorporated 3D capabilities within Runtime in a number of releases, actually. So our first release in this new Quartz generation, this new next generation of Runtime, was the end of 2016. In that initial release, we supported 3D commercially on desktop products, on desktop platforms. In Update 1, which was 100.1 last June, was the first time that we actually fully supported 3D across both desktop and mobile platforms. And so since that time, we've been enhancing feature functionality within 3D and Runtime. And so right now, the latest release is 100.2.1 for all Runtime SDKs. That rolled out about 2 weeks ago. And what we're going to do is we're going to take a look at these fully supported capabilities across every SDK and across every platform that we target support for. This includes a couple of different categories. So support for scenes, actually the ability to sort of curate and organize 3D content, elevation sources, a variety of different layer types that are specific for use within 3D, Symbology that's designed for 3D display, and then a set of view controllers that enable us to more readily work with our perspective within a view, and then also some analysis capabilities that were added in recently. So we're gonna do a little walkthrough here of some of these capabilities, and then towards the end we'll have a demo here and show some of these capabilities in action. So the first section to focus on here is a scene. So think of a scene as really a mechanism or a document for being able to persist the layers and configuration or symbology associated with your 3D view, actually. Within Runtime, we have something called a scene view, and this is a UI component to control, and that scene view can have transient information, but it also contains a scene. Right? So the scene itself is something that's persistible. It's something that is built on top of a common specification. In this case, we're looking at built on top of what you can do within a web scene. And so the web scene defines as a common document that's shareable across the platform capabilities that we need to be able to persist and then share and then utilize. So the ideal here is that the web scene provides a consistent experience that we can read from and write to. And we can share that with JavaScript or web apps. We can share it with Runtime, other Runtime apps. We can share that with our desktop apps too. So really centered on the scene view as the control within the API, the scene as really a container for your layers and symbology associated with your contents within that scene. And then within the scene view, you have things you can overlay on top that's very specific to our API implementation. So think of a set of containers that are they're basically going to be containing your 3D content or content that's designed for displaying a 3D context. So the next thing here is scene layers. So scene layers are a specific type of layer that are optimized for display within a 3D context. Scene layers are based on the I3S specification. This specification is a public spec. It's been certified as a public spec as of the end of last year. And this specification defines really a structure for being able to cache three-dimensional data in a variety of formats and then be able to optimize that content for retrieval and display in a number of clients. And so it's a public spec. If you go out on github.com, you can go to the I3S repo right now. You can actually visualize the specification that's available. This is the spec on which we're building scene layer functionality in every Esri product. So whether you're working in desktop or you're working in Runtime or JavaScript and you're working with scene layers, you're using the I3S spec, or we're building on top of the I3S spec. So right now, there's two different formats of scene layer that we work with in Runtime. 3D objects, which is really a cached format of a multi-patch, sort of 3D volumetric feature. And we also work with integrated mesh. This is a triangular mesh of data that provides you with basically a surface, a triangular mesh or a tin that is actually rendered as a surface and then hosted as part of I3S as an integrated mesh that then you can use, drape on, display, but it's effective. The I3S standard defines an optimized mechanism for retrieving that information for display in 3D. Excuse me. There's a couple other formats here that we're looking to target here shortly. Another one is point cloud. So you're starting with LiDAR data in some capacity, and there's a variety of different renders associated with being able to display large amounts of point data. But being able to cache that in a format that's easily consumable. So we're talking about tens, if not hundreds of millions of points, not billions of points, and being able to render that effectively is something that I3S is supporting and that we're looking to support in Runtime. There's also the ability to host cached feature types other than multi-patch. So if you want to be able to create points, lines, or polygons and cache those in a mechanism that can be used in a 3D context more effectively, so you're not just looking at scale, but you're looking at distance from your camera and being able to retrieve the features that are necessary for rendering and use, that's what I3S is optimized for. So we've got a couple of different gaps there that we'll be looking to kind of mop up over time within Runtime. Granted, some of those specifications for those formats are still in flux, so we're still working with, within Esri to make sure that we can flesh those out. How do you access these today? So there's two different ways. One is through a scene service. And so you can publish these formats actually into a scene service. That scene service is viable for both ArcGIS Online and ArcGIS Enterprise. You will get a coupled service with it, actually, so a buddied service. So you'll have the scene service, which hosts the I3S specification for cache data. You also have a feature service that will actually have the underlying features and attributes associated with that data. There's another option, and that's scene layer package. So scene layer package is really an archive that contains all of the content that would be representative of the cached 3D data. Scene layer packages can be created today from Pro. So if you have a 3D content within Pro and you want to be able to create a scene layer package for use in Runtime offline or locally, you can do this today. The scene layer package standard is part of I3S, and so if you want to be able to create these yourself, we actually have a number of vendors that do create scene layer packages and distribute their three-dimensional data in this way. You can leverage that specification for archiving that data and distributing it. Okay. Of course, in 3D, you're looking for something. You're usually looking for obviously a realistic experience, and that usually involves elevation. Right? There's height associated with features that exist within your 3D experience, and so elevation sources is a critical part of our 3D experience. So basically, within Runtime, we can associate our height or our sources, our surfaces, elevation sources for surfaces, to multiple sources. And those sources include an ArcGIS image service. So if you look at the global elevation service, that's an ArcGIS image service. It's using something called LRC encoding to be able to build out the tiles that are designed specifically for elevation use, not necessarily for display directly, but they're designed for elevation. This is something that you can create in Enterprise and Online today. You also have the ability to publish this through Pro. So if you want to take your elevation sources, which might be coming from DEMs from a variety of different raster formats, and you want to cache that in a way that's effectively used within a variety of Esri products, including Runtime, you can use the LRC encoding imagery format actually as an image service via an image service endpoint. But just like with scene layers, you can actually take this offline, right? So Pro does offer the ability to create a tile package, not just for display, but for elevation use, right? So you want to take those same lurking coded tiles, take it offline, you can do that as well. Now granted, these are offering basically if you're creating a tile, basically a tile package of your raster data, then you're actually just getting a picture of your data, right, at different levels of detail. If you want to work with your raw elevation data as rasters themselves, we support that as well. So if you're working with local raster files, you can work with many at once. You can package these in a mosaic data set and utilize those within Runtime Today. Right? So all of those are sources that you can use for elevation. Right now, we only support above ground navigation at this point, but we're looking to be able to accommodate for below ground or subsurface navigation. It doesn't mean you can't see things; it just means you can't navigate below the surface, right? But the surface that's defined by an elevation source will define the context in which you can maneuver and navigate within a 3D scene. Great. So another addition that we added recently in the last update, so update 2, is the ability to take advantage of dynamic rendering. So there's two different rendering pipes within Runtime. One is static and is really CPU-based, CPU-intensive, and then one is dynamic, which is GPU-intensive. Static rendering mode is, in general, the default for feature layers thus far. And what that means is that basically we're using the CPU to be able to render lots of data, so we can actually take advantage of CPU resources and in-memory resources to be able to render lots of data, but the responsiveness isn't as ideal as you'd expect with that. So inevitably, as you zoom in and out, you're going to see this sort of granularity and then crisping up of those features, of those symbols associated with those features. So while you can render a lot of data, the experience as you navigate through the scene is a little bit compromising. You also, within 3D, it's a little more noticeable because they're always draped, right? So you're always draped on a surface. And of course, because you can work with different oblique perspectives in 3D, if it's always draped, then and you want to be able to see or at least highlight features, it's easier to be able to billboard those features so they're more front and center and always facing the camera. So we did have a solution prior to update 2 that allowed for you to take your feature layers or features that are stored within feature services or in mobile view databases locally and convert those into graphics, right? Because we have two different options for displaying vector data, graphics and features. We allowed for folks to be able to convert that, but it was kind of a labor-intensive process, right? To go from your features to a graphic, and those graphics were transient, right? These existed outside of the scene. These were part of the scene view. So we wanted to be able to provide a more direct mechanism for being able to work with your features. In addition, we wanted to be able to optimize the display capabilities here. So there were some refinements that were made within our display pipeline to be able to accommodate for a dynamic capability or dynamic capabilities within 3D. And so we were able to do that in update 2. So you have a better experience. So while feature data might come from a variety of different sources, services, local data, like is mentioned here, we want to be able to, regardless of where it comes from, we'll be able to render it quickly and effectively. So instead of having to convert it over to another format, so to just work with them directly. So this is an example of a static experience. Oh, is it going to show? There we go. So there's an example of a static experience in 3D where you're zooming in and you can see things kind of get coarse and then crisp up, right? And as we tilt, you'll see that it drapes on the surface, so it's kind of difficult to see, how the point features themselves are actually matched up, right? So we'll tilt here briefly. Right, so a little bit flat there. So obviously this is still supported, but this is the only way that it worked actually prior to update 2 for feature layers. You'd have to convert into graphics for this actually to be more dynamic. Now being able to leverage the capabilities of the onboard GPU to be able to take advantage of this dynamic rendering pipe and this dynamic experience, you can see as you zoom in, right, we don't see it crisping up, everything maintains its sort of fidelity. And then as we start to maneuver and manipulate, you can see they're always sort of facing the camera, they're billboarded, they're face up, and the experience there is much more fluid. So being able to optimize and create a rendering pipeline that accommodated for this was critical that we did in update 2. Of course, not just being able to billboard marker symbols, but being able to work with features more effectively to use model symbols, three-dimensional symbol types that you can work directly with your features or extrude. And we'll see this in a sample here shortly, being able to work more effectively with your features directly. A couple things to keep in mind here. When displaying features actually in 3D, there's a variety of different ways you can do this, right? So I just mentioned two, if we're working with static or dynamic, but there's a variety of other ways to work with large amounts of data as well. When I talk about the first two, point scene layers and point cloud scene layers, I'm just talking about point specifically here, depends really on the source of the data and then what you intend to do with it, actually. So if you're working with a lot of data and you want to just be able to display this information actually within a 3D context, then a point scene layer might be ideal because it would be optimized for a 3D context. We don't support this yet, actually, but this is something we intend to support shortly. Point cloud is actually, because you're gathering this data in a different way, and you have a set of different renders for rendering large amounts of information that are usually gathered as part of a point cloud or originally started as LiDAR or LAS data. Point cloud provides some optimization for those scenarios. So vector tiled layers, another option here. So vector tiles are something that was originally designed really for a 2D experience, but because we see a lot of folks actually changing their base maps out from raster to vector tiles, they want to be able to take advantage of sometimes the size, but in generally the performance and the versatility of vector tiles, because you can change rendering on the fly, but still work with really a cached level of detail associated with vectors. That would be one way to support working with vectors within a 3D context. Unfortunately, we don't actually support that yet. We're still looking at ways to be able to accommodate for those experiences in 3D. As an example, Pro supports this, but what they do is they basically rasterize the tiles right now. So basically what you're doing is you're taking vectors, you're rasterizing and draping. So you're not really getting the full sort of 3D experience that you'd expect, where oftentimes with vector tiles, you have symbology and labeling, and you'd like some of that to actually respond to the orientation of your field of view and your perspective. We don't get that yet, but we're looking to be able to achieve that. Last part here is multi-patch geometry. So this would be basically the source for the 3D object scene layer, right? So think of these as 3D objects, 3D features, right? Volumetric features. Eventually, we'd like to be able to support this type of workflow so that if you're looking at building an editing experience, where you're actually managing or manipulating three-dimensional objects in space, and you want to be able to use Runtime as the editing front end for that. The back end might actually be a feature service that hosts multi-patch geometry that exposes those multi-patches in a way that then you can render and then manipulate those. That would be key as well. We don't support this yet, but again, it's on the roadmap. So a couple things there to keep in mind with respect to capabilities when working with feature layers in Runtime. 3D symbology. So when working with features in 3D, there's a variety of different capabilities that you'd like to take advantage of usually that don't really match the 2D perspective, right? So being able to take advantage of your 3D perspective by extruding features based on their symbology, based on some sort of attribute value is pretty critical. And so that's something that we support now at this stage. We'll see this in a sample. 3D marker symbols, we have a set of marker symbols out of the box. So instead of working with a circle, you're working with a sphere. Instead of working with a square, you're working with a cube, right? So a variety of things that really take advantage of that 3D capability. So a few things supported out of the box. Model marker symbols, these can be something like complex models, come from a variety of different formats. We're built on top of ASIMP, which is the open asset library. And so generally the formats that are supported by that library will be supported within Runtime. An example here would be the ship. So really this is a point on the surface of the Earth, and it's being represented by I think it's a wavefront model. And so you can get quite creative, actually, with what you want to display. Now, keep in mind, this is all being displayed at this stage using our dynamic rendering pipe, right? So it can be memory intensive at this stage. So you got to be careful, how many features, how much complexity you add to this the rendering pipe associated with this. Another symbology specific feature or capability of Runtime is distance composite symbol. So you want when you're working in 3D, it's not just scale, but it's also distance that you're worried about or you're concerned with. And so as you get further away or closer to a specific point, what we want to be able to do is provide you with almost a sort of a distance dependent renderer, right? So as you move away, the renderer actually becomes a render that you define like distance composite through a distance composite symbol. That symbol is, let's say, less complicated as you move further away from it, right? Because you don't need to render with a certain level of complication and really tax resources associated with the system. As you move closer and you need that higher fidelity, you might change the symbol to something that's a little more respective of what the object represents. So you have control over how symbols are displayed based upon the distance from those features that are using to render that symbol. All right, so when working within 3D, again, working with cameras and different viewpoints and different controllers for adjusting those cameras and how they work are pretty critical. So the camera itself, as far as an API is concerned, provides a variety of different properties that you can use and you can leverage to take advantage of so that you can orient that camera in its perspective to change the view. Of course, as a developer API, you can program against this, right? And so we have a couple of different properties that enable you to create the camera and manipulate its location. One thing, it's an example would be rotate around, which there's some convenience methods in there to be able to sort of accommodate for common workflows. If you want to be able to focus on a specific point and just rotate around it, it's fairly common, so we add some enhancements within the API to support that. A couple things to keep in mind here too is that we're not necessarily working with extents in 3D, we're working with viewpoints, right? So these viewpoints are a bit more complicated than just an extent. And so we're looking at a variety of different ways to work with a viewpoint, and that might involve a geometry that has, or a geometry or a center and scale, actually. And so it's a measure, it's a way of working with or being able to associate with a specific perspective or location within a 3D context that doesn't involve a specific extent, a viewable extent, or that extent is actually different than just a rectangular extent that you'd find in 2D. And so that viewpoint allows us to calculate for a camera position or geometry or working with rotation associated with that camera as well. So a couple different things to think about. The second column talks about controllers, and these are just ways to, built-in ways to be able to navigate your scene more effectively. So by default, you'll have a globe controller, which means you can navigate the globe freely. But you can also lock that to a specific element, right? So a geo element, which would be like a feature or graphic. So if you want to be able to follow a feature or graphic and tie your navigation to the orientation of that feature or graphic is key, a geo element. Another one is just a location. So being able to pivot around a location, you define a location without an element per se, and being able to orient your camera associated with that location specifically. Just a convenient mechanism for doing that. And with that, we're going to dive into a set of demos. Adrian's going to walk us through some of these capabilities that we have today.
Thank you, Rex. That works. So I'm number 5. I'm going to have a really easy demo set because all I'm going to do is showing you what you can download from our website or from the app stores, and just show you a set of samples of things that we have been working on for the past year that came out in the past 2 releases. And you can really easily download the bits I'm just going to point you to, and then download the sample app for your particular API, and then look at what the sample does first, and then explore the source code. It's just all in the self-contained application, and it's a really easy way to get your first step inside the 3D applications on the ArcGIS Runtime. So I'm right here on the developer.arcgis.com website, and that's a really good point to start regarding all our developer technology. So some of them are not runtimes or JavaScript, and like the REST and Python API are not, but all the other ones are the runtime API that Rex just mentioned in one of his first slides. So if you're like, for example, a .NET programmer, you just go to the .NET section, and it will give you right away, you can download the SDK, install the SDK, and do a bunch of, start diving in, and that web page is definitely where you want to go and where you want to start. If you're an iOS developer, or maybe I should try a Java developer. You have exactly the same. It looks exactly the same. You have the same experience. Once again, we did that work inside our API. That Rex mentioned that we have now a command workflow, and then we have a small common API that allows us for each API to have the same functionalities. We did the same work for our web page for developer experience. And in a lot of them, you can just download the samples, and that's pretty much all I did, is download the samples and run it. But the first thing I wanted to show is actually what we released at, or focused for update 1, was actually running 3D on mobile platforms. So we worked a lot on getting all the 3D functionality we had at the time and be able to run it on smartphones. So what I have here is the App Store, and you can, if you have an iOS device, you can just go to the App Store and download the ArcGIS Runtime SDK samples, and that's pretty much what I'm going to use for the next 2 demos. And so the first thing I wanted to mention is it's not completely new, the ability to look at the view scene in 3D, scene layer in 3D, but be able to look at it on a cell phone and performing that well is something that was new at update 1. And once again, you have an iOS device, download the sample and play with it and see how it performs. Then I want to dive to new functionalities that we added at update 1. And Rex actually was the previous slide about it. It's a camera controller. So what's happened here is now I'm actually decided that I'm going to follow that plane, which means that it changes my interaction. Now when I pinch on my screen, I don't go looking at somewhere in the Grand Canyon. I actually always have that plane centered. So I can rotate around and see how it goes. But because I'm using a camera controller, which is a geo element in that case, which is my plane, I'm actually always having the plane in the center of my screen. There's a lot of things you can do with it. You can obviously, by code, set the distance you want, or you want the heading offset. I can try to put the heading offset at 0. Pitch offset, the same. And then you can decide that you're going to have your camera moving with the plane, or you can decide, no, I just want my camera to look north instead of actually looking at the same heading as the plane, which I'm going to re-enable right now. And now I'm actually, the camera will also change its heading following the plane. So that's one of the new functionality we added because a lot of people ask us, I told us it was actually pretty hard to do without that camera controller before. So if you want to look at the code, I'm still inside the application. And so I have information about the samples, and all the samples that are in the app have the same description. And then you have the code. So here it's obviously an iOS code. And I cannot highlight because I'm in an application. But you can see, hopefully, it looks pretty clear on the screen. But you can see on the end that I'm basically creating my camera. I'm adding my plane, a 3D plane, and then I'm setting up my camera right here. So it's called an Orbit GeoElement Camera Controller, and I'm setting a bunch of properties to it. But you can just download the samples and look at the code. And so we have samples for a lot of things in 3D, and you can just look at it right from your phone. Now, I'm going to continue and try to move on to this time a desktop API with a Mac OS API. So once again, you can download the sample app called ArcGIS Runtime Mac OS Sample, and you have a link from the developer website. And this time I'm going to talk about the new functionality that we added at update 2, which is a view shed. So the view shed allows you to actually select a position and be able to say, if I was at this position, what will I be able to see? So you can set a field of view, because we don't see too far on our side. And then basically render everything in red that it's in the field of view, but it's just hidden from you, or in green, something that you can actually see from that position. Because, as Rex mentioned, it is not on the GPU, it's actually performing really well, and you can actually just move your mouse and get that calculation done instantly. You also have here parameters that you can do, like if you want to have that kind of radar approach where you just zoom around what's around you. And all those properties are accessible to make sure that you can hide the view shed in your application that correspond to exactly what you need. Once again, description of the samples, and then source code. So this time it's a macOS source code, and you can see exactly how we will set up the view shed. So it's just basically calling a new ArcGIS location view shed, and then we have that layer called ArcGIS overlay, which is an analysis overlay layer. that you add your viewshed to that layer, and then you add that analysis overlay to your scene view. And then it will display that viewshed. Now, because we can follow a plane and we can do a viewshed, let's try to combine those two things and be able to do a viewshed from a geo element. So this time it's a tank working on the city. And I can actually click somewhere, and it will actually direct the tank to that location. So I'm using the both functionalities that I just showed you earlier. I'm following the tank, so I'm using the camera controller, and I'm using a viewshed, which allows me to render the position from the tank and see what the tank will see while it's moving on the city. And once again, if you want to dig inside the source code, just go to that tab, and you'll be able to know all the information about how you can write the same experience for your application. So we did iOS and macOS. Now I'm going to move to the Java SDK. So we have another application, ArcGIS Runtime SDK for Java. And this one is a line of sight. So it's kind of the same principle of the viewshed, but here you're just interested between an observer and a target, and you just want to see, can they see each other? And all I'm going to do is, by clicking on the map, I'm actually putting a new target point. Actually, I don't even need to click on the map. So as I'm moving the mouse, I'm moving a new target point, and it is drawing a line between the observer and the target. And then it's telling you until, from the observer to the target, everything is green can be seen by the observer, and when it's red, you cannot see anymore. So obviously, if I'm on the other side of the mountain, they'll be able to see each other. But if you do have a mountain in between, then it will not go through. And that's all done on the GPU once again, so it's actually really quick calculation, and really helps some of the analysis that you might want to do. Once again, information about the sample, and then you can look at the code. And this time it's some Java code. And I think the viewshed analysis, voilà. So that's the line of sight. That is a new location line of sight. And once again, it's just an analysis. So you just add that to your analysis overlay, and you put that in your scene view. And that's how you create a line of sight. And the last demo I wanted to show is, I'm going to use, let's use Qt this time. So it's the Qt sample apps that you can download also from the developer website. And that's to accentuate something that Rex mentioned earlier, is that before, when you were connecting to a feature layers, you could retrieve all those features, but you could only have them static. Static is a good mode if you want the text to be draped on the ground. So it's actually something that you might want to use, and we didn't take that away. But now we added the capability of having a feature layer in dynamic mode that allows you to get those features to actually pop up in 3D. So the text, instead of being draped to the ground, will be always facing the camera. Wherever the camera is, it will be safe facing the camera. So before, to get the same experience, we'd have to take your features, query them, and then add them to a graphic overlay. Now you can do all that work directly inside the feature layer. So you have a feature layer connected to your feature service, and now you can right away do things like extrusion. So here all I have is a population density. Actually, no, that's the total population inside the US per states. And you can see that California is way ahead, and Texas is pretty high too. But if you change population to population density, you're going to have a really different experience. I think that sample is pretty slow for some reason. But the extrusion is something that you could only do before by copying those data back to a graphic overlay. Now you can do it natively inside your feature layer. You don't have to change layers to do it. And once again, you can go from the live sample to the source code and see how simple it is. So actually, that's way too simple. I think it's missing a bit of code. But it's really as easy as saying I have a feature layer that connects to that feature service, and then be able to display it directly. It seems like the calculation of the total density doesn't want to work, so I think we're going to pass it back to Rex, but I will show it to you because the two samples are give a pretty different effect. Back to you.
All right, good stuff. Great, thanks, Adrian. So one thing I wanted to highlight there that was new, and just kind of call it out, actually, is the analysis capability that Adrian demonstrated. So I just want to follow up with a slide here to talk about exploratory analysis and the analysis tools that we're adding natively within Runtime, actually, right now. So exploratory analysis is a concept that's being introduced across the platform. So we're finding tools that are introduced in Pro, those same tools are being introduced in a developer context within Runtime. They'll be available in JavaScript later this year. But exploratory analysis is really designed to be sort of visual and interactive. This is transient information that's being presented or provided that uses only the data that's visible in the scene, right? So it's designed to be optimized for basically visual display purposes. So it's not designed for really conclusive analysis where you're going to be storing that information and using it in further calculations, right? It's designed to be GPU powered, so leveraging your GPU at best to be able to provide this sort of interactive experience. And we've introduced a couple of different tools here in this Update 2 release at the end of last year. First one was line of sight, which we showed, we took a look at in the sample, but also viewshed. And so both of these experiences, while being added to Runtime, should match what we find in Pro. And when these are available within JavaScript, the same experience should be available there too, right? So we'll have a very similar experience across the multiple clients that are part of the platform as part of this exploratory analysis effort. And we'll see here in the road ahead here, there's additional tooling that we're adding. We want to be able to do this consistently across the different clients within the Esri platform. Just wanted to highlight that briefly here before we dive into the next slide, which is the road ahead. So first, I'll look back, right? So I'm going to look in the rearview mirror a little bit just to kind of highlight some of the new features and functionality that we added in 2017 to further enable 3D capabilities. So as Adrian mentioned, as I mentioned earlier, we provided full support for mobile platforms in 2017. So now we provide full support on all desktop and mobile platforms across every SDK, right? So this was what was kind of critical here is improving memory management to work with limited device resources and being able to utilize the rendering pipelines that are available on mobile devices, right? So there was some work that needed to happen there. That's under constant refinement at this point. We added camera controllers to be able to follow a geo element, which is pretty critical, so that we could actually get those sort of almost pseudo navigation experiences behind a vehicle, and we could track and utilize those, and so that we needed to manage our rendering mechanism to be able to accommodate for that type of update. Local elevation from TPKs was another thing that we added here recently. Instead of just working with raw rasters, individual raster files, you can use TPKs with lurk encoded imagery. Why is that important? Well, because if you're looking at licensing within Runtime, if you need to be able to work with local raster files directly, that's part of standard. That's a cost associated with that license level. If you want to work with lurk encoded tiles within a TPK, it's part of our light license level, which is free, right? So that's why that's important, cost. We added support for a number of different standard formats that were also included in 2D, whether it's WMTS, OpenStreetMap, web tiled layers, WMS, and shape files. It also includes geo packages and working with rasters, obviously, and displaying those rasters within 3D. ArcGIS Image Services was a critical addition here, too. For analysis, we added viewshed line of sight. We were looking at including measure at this point, but measure is actually transitioned to our Update 3. Dynamic feature layers is something we spent a little time on before, just enhancing our rendering options for feature layers and regardless of where the features come from. And WGS84 tiled layers. Right now, our tiled layers within 3D need to come from a web mercator. It's a global perspective. There's no local support yet. But tiles up until this point, up until 100.2.1, which is our release from 2 weeks ago, need to be available in a web mercator. And so if you're working with tiled sources from for a base map, or tiled sources associated with a TPK, whether it's for elevation or for display, they need to be in web mercator. At this stage, WGS84 is now supported, right? So from a global perspective, we support WGS84. So that's work that we've done thus far. This is in the current release of the products across the board. What we are looking at in Update 3 is a couple of, and Update 3 is scheduled for June 2018, is some additional feature functionality to kind of bring us closer to platform capabilities that we see within ArcGIS. And so one of those is reading and writing web scenes. So I mentioned before that web scene was a standard specification for basically serializing and exchanging information about the context and the contents within a scene. Right now we have managed support for most of what's in a web scene. We just need to provide a mechanism to be able to deserialize and serialize within Runtime. And so that level of support is actually what we're adding right now. We're putting it into the API to be able to support that out of the box. Mobile scene packages. If you're familiar with mobile map packages, this is really just instead of a map, this is a scene, right? And working with all the scene capabilities, some of which we covered here, which is scene layer types, working with elevation sources and different symbology that's specific to 3D. But being able to build out a mobile scene package and deliver that in an encapsulated archive is pretty critical for folks that want to be able to go offline, right? And they've got a pre-planned workflow where they want to be able to build out a solution, sideload this or get it on a device, and then be able to take this offline and work with it locally. And being able to do that in an encapsulated manner. The next item here is scene layer select and identify. So now we can display scene layers. We just need to be able to interact with what's in the scene layer, right? So this seems relatively straightforward. You want to be able to interact with, highlight, and also get attributes associated with a feature or an object that exists within a scene layer. So something coming in Update 3. Point clouds, so being able to point the point cloud format that's defined as part of our i3s spec for scene layers coming as well. We'd like to support vector tiled layers. We're looking at, maybe we follow the pro workflow where we drape it initially and then we actually provide a more immersive or 3D appropriate experience. But we're going to see where we're at with that one and see what we can provide. Ideally, if it's draped, that's not the first or last iteration of supporting vector tile layers. Ideally, what we do is we get to a point where we can actually represent vectors within the vector tile layers appropriately. So we can billboard labels. We can orient and change labels appropriate to the perspective within 3D. Or we can actually billboard features actually within those vector tile layers as well. So analysis. Analysis in this case has been split into a couple different places, a couple of different operations. One is measure distance, and providing an out-of-the-box measure experience that you have that's similar to Pro and similar to what we have in JavaScript, but in Runtime. Again, it's just a visual experience. Behind the scenes, with our geometry engine, we'll be enhancing more discrete, more precise calculations available through geometry engine to do three-dimensional measurements and calculations. And so these are a couple things that we're planning for Update 3 that'll be out in just over 3 months, actually, at this stage. So a couple things that we're looking at. There's some additional analysis tools that we're looking at towards the end of the year. One of those might include something called a view dome, which is really kind of like a three-dimensional view shed, if you think about it. And also looking at other mechanisms to support measures, such as measure areas, so that we can incorporate those more consistently across the platform. Is anyone actually building a 3D app today, actually using Runtime? Anybody? Okay, no. Okay, good stuff. So you guys do you guys intend to build a 3D app within the next year? Actually, most folks? Okay, good stuff. Okay, cool. Anyone, you guys using, do you know which SDK you plan to use? Is it probably going to be, assuming Runtime, is it going to be .NET? Okay, any iOS? iOS, okay. Any Android? A couple there, okay. Qt? You're going to use Qt? Okay. Anyone else using Qt, actually? Back over there, okay, cool. Anyone using Mac? Okay, I was wondering if that was going to happen. Yeah, okay, good stuff. How about Java? Java and Mac, no? Okay, good to know, good to know. Okay, great. Now, so with that in mind, I wanted to go into something that you may have been in a session already. You've heard about some of the work that we're doing in virtual and augmented reality within Runtime. And so this is a slide you might have seen in another session. Obviously, it kind of goes back to the plenary, at the very tail end of the plenary, we talked about an offering that we have with Runtime. And it really it makes sense. A lot of folks are looking to be able to take advantage of a native experience, and so they're building out native solutions for devices that they want to be able to provide a VR, AR experience. And so we're looking at, in Runtime, we're looking at two options. The first option is just taking the 3D experiences we have in Runtime today. and just providing a different perspective so that we can accommodate for VR and AR experiences, right? And so we manipulate our rendering pipe that's associated with Runtime to be able to accommodate for a different perspective for VR, so basically taking the scene and creating an appropriate rendering mechanism to be able to split that into a stereoscopic view and have it update and perform readily so that we've got a good frame rate so you don't get sick. Actually, when you're working with VR, it's kind of critical. And the other part is with AR, just being able to remove portions of the scene that might get in the way of being able to overlay your virtual content on top of a camera feed, on top of a representation of physical reality, right? And so being able to make some changes within Runtime to be able to support that. We have a private beta of this right now. The private beta is invitation only. Actually, I didn't put the email alias up here. Is it on the next one? Oh, okay, good stuff. So the private beta is available. Actually, we'll get to that shortly. I just want to cover this last section really quick. So we do have a private beta. We'll talk a little bit more detail on where that's at in the next slide. The second option here is integration with game engines. And so integration with game engines is another option that we're looking at being able to better provide a mechanism for access to data sources and operations that are available as part of the ArcGIS platform and integrating within game engines. So if we're working with, let's say, Unity or Unreal, and being able to not have to reinvent their rendering experience, but really just kind of allow for a plug-in of online or local data that might be live streamed or updated regularly, and have that be represented appropriately within a game engine experience. So you can build out these more immersive, more responsive, generally more just a richer experience for 3D in general, let alone VR and AR. And so we're looking into solutions for being able to refine what we do in Runtime to be able to hand off information in a more efficient manner so that game engines can take advantage of it. To make it simple, probably lighter weight than what we have now because we don't have to handle the rendering at that point. And so being able to, obviously it'll power 3D experiences in game engines, but obviously a number of different device makers and platforms that are looking at targeting this sort of mixed reality, this immersive augmented reality experience like HoloLens or Magic Leap or Vuzix. Actually, they're building out headsets now that their developer environment is using a game engine, right? And so they want to be able to, we could see where folks that are using the ArcGIS platform have built out a set of authoritative data, and they want to be able to utilize that in that experience instead of having to manually bring it in, which is what's happening right now. So we're looking to enhance that experience. Great. Okay, so a little more detail on the private beta program. So we started about 3 months ago. We're targeting high-end devices generally. So in this case, you need to have a device. Ideally, you've got a device that, a more recent device, it's got a high-end chipset, it's got a lot of resources. Hopefully it supports one of the AR frameworks, like ARKit or ARCore, iOS and Android, so that you can take advantage of this sort of localized or relative location awareness for that device. So it's ideal that we target some of the higher-end devices. Right now, we're just delivering .NET, iOS, and Android at this stage because most of the requests that we've had in this area have been either targeting Windows desktops for that premium VR experience like you get with Rift or Vive, or these mobile experiences on iOS and Android that you want to slip into a cardboard, and deliver at a low cost. And so .NET, iOS, and Android have targeted a vast majority of the market. It's built on 100.2, so basically it's Runtime 100.2 plus some additional features, right? And those additional features enable these VR, AR experiences. The key here is we'd like to be able to take this out of private beta and make this commercially available in a product this year. And so it's critical that we get some feedback to indicate whether or not the API is usable. This is functionality that's viable, actually. Of course, the beta includes samples and toolkits, documentation to get you started, right? So it's sort of an all-encompassing site to get you up and running. If you'd like to get access to this, you can email this alias, and we'll try and get you in as soon as possible. So let us know. And with that, we can take some questions. I think we've got about 5 minutes left, actually. So we can take a couple questions, and then we can take it offline there, too. So any questions thus far? Yeah, back?
Yeah, do you have local scenes in the roadmap?
Local scenes, that's a good question. We do have local scenes. When we support the web scene, so the web scene specification defines global and local. The initial level of support for web scene will be global because that's what we have managed support for. Eventually, we will target local to be able to more fully accommodate that web scene specification. So ideally, we'd have it by the end of the year, but I'm thinking this is probably going to be into our update into 2019, just seeing with how things are kind of playing out at this point. But it's certainly there. We're not going to let it slide. Eventually, we're not going to ignore it. We're certainly going to tackle it. It's just probably not this year, seeing what we need to do. So, good question. Yep. Any other questions, guys? Yes.
We saw the flying plate
Mm-hmm.
in your demo, and you didn't say anything about real-time objects in this environment. So, what's the target? Are you going to integrate real-time moving objects in this 3D environment, or is it just?
You can.
How did you do it?
Yeah. So you can actually. So there's a set of sort of platform, I guess, options actually for including real-time data, right? Some of this is built on top of what we call our stream services or stream layers, right? And being able to plug in those stream layers as real-time data, but then use those in 3D, isn't necessarily you could leverage what we have in Runtime Today to take advantage of those capabilities. So for example, if you want to work with stream layers, a lot of times the communication mechanism there is built on WebSockets, right? And inevitably, when you boil it down to what needs to be passed back and forth, and you can get access to that data, that information, then it's usually more about just pumping it into the rendering pipeline that Runtime provides. So while we don't provide, like for example, for scene layers or for stream layers, we don't provide out-of-the-box support. It's not keeping you from actually building a solution that takes advantage of that real-time data workflow, actually. So you can still build it, and the rendering pipeline will handle it. It's more about getting that information in at real time, and then being able to update and render within your scene, which is Runtime is perfectly capable of doing that, actually.
A good example, I don't know if you saw the plenary where actually Rex and I were interacting and Rex was moving and the viewshed was updating as he was looking around. That's kind of an example of data that is updating constantly, that is passed to the runtime, and the runtime just render it in real time and react to any changes to it. So we don't have the mechanism to actually pass that data directly in, something that you will have to write. But once you have that feature coming in at move position, the runtime will be able to change position or any analysis that is associated with it and run it very well.
Yep. So as a developer product, it's flexible, right? So we do provide the graphics and a feature engine to be able to render and symbolize this information. It's more about, well, how are you getting the data in? Like how's the data fed in? If you're using something we provide like stream layers, then there's a mechanism for doing that. Actually, now if it's some other sort of a third-party messaging system, we can do that too. Actually, right? So it's just a matter of the mechanism underneath the covers to bring that information in. Once it's at Runtime's door, and you can actually use then to draw and render that information appropriately. Yep. So. Mm-hmm.
Then another question, if I may, can you directly connect all of those features?
So. With the public beta or the private beta that we have right now, you can build a UWP application, right? And UWP applications you can deploy to the HoloLens device. It's not specifically designed for that, though, right? And the reason why it's not designed for that is that we're handling all of the rendering ourselves, right? So if you want to be able to overlay and interact with other content within your sort of augmented experience, you'd have to be able to add that to our rendering engine, right? Or supplement on top of our rendering pipe. And so you're not working with. Whereas in a game engine, ideally you're working with granular components, granular objects, right, that you can control, you can modify, you can manipulate. But then Unity itself is actually, or the game engine itself is responsible for managing the rendering of those objects discretely, right? So you could do it technically. You could provide basically like a full-size view where you supplement or you overlay three-dimensional content in your UWP app, but trying to get something to work with it, actually. Other things that show up within your augmented experience means they'd have to get into runtime somehow, right? Yeah, so you could do it, but it's not designed for that, right?
But the gaming engine approach that Rex mentioned 2 slides ago is basically you'll be able to target HoloLens using once we have that implemented.
All right. Yep, you bet. Okay, guys, we're right on the top of the hour.
One more question.
Oh, I'm sorry. Yes. Right. So there's a number of, we know as well, this is kind of like local scenes, like we know as well that there's certainly a demand for being able to navigate and view to navigate and then actually interact with or work with subsurface content. I think the key there is that it's not that you can't see it. Actually, it's that you want to be able to navigate beneath the surface, right? And so we're evaluating different mechanisms for being able to navigate below a surface and be able to attach to specific content that enables us to be able to navigate effectively. In addition, we also have just maybe a little bit of transparency because we're actually considering that we're just navigating above a surface, that sometimes we hide things below the surface, and so we need to manipulate how that's viewed so that I guess the fidelity of your display isn't compromised somehow. And this is kind of a situation that we're looking at with other products too. So, so Pro actually has the ability to navigate, but it can get a little bit hairy actually at this point. So we're looking at better mechanisms for being able to navigate subsurface. Certainly on the roadmap to be able to tackle. Again, it's one of those things where we'd like to get something kind of fleshed out and consistent across product experiences where it makes sense. So whether it's desktop or runtime or JavaScript. But it's going to take a little time to flesh that out. So, but it should be there. I would imagine this is kind of on the same path as like the local scene approach, where we need to support that. Probably end up being 2019. I suspect that subsurface navigation will probably end up being early 2019. Actually.
So to be clear, you can look at subsurface data, but from above the ground right now.
Yeah, it's just navigating below. Actually, is the difficulty at this point. So yeah, it sounds easy, but yeah, there's some complication there. We need to make sure we're all on the same page at Esri, actually, too, ideally, right? So it's not a different experience depending upon which client you're working in, right? So that'd be ideal. And with that, I think we're a little bit over time. So thanks for coming to the 3D session, guys. If you have any further questions, feel free to come up. Otherwise, enjoy your conference. Great, thanks.